Hello everyone, welcome to session 6 of Genomic Variant Analysis and Clinical Interpretation Workshop. Today we will do hands-on annotation of variants and their literature attributes. We have 5 examples in this session and we will take each one of them individually. The first variant is R481W in XYLT1 gene which causes tubercular dysplasia 2. The first step towards annotating these variants is to fetch their different IDs from databases such as VEP. Since you have already learned how to do that in previous sessions, I have gone ahead and fetched these IDs for these variants. And this is the gene name, the cDNA position and change, the protein position and change, and the RSID for this variant. So we will mine the literature using protein change first. We will put in the protein change in different databases such as Google Scholar, PubMed, and PMC, along with the gene name. So let's do that. So I have already put in XYLT1 R481W in Google Scholar, and as you can see, I have gotten 12 results for this. We have to click on each one of these results and check by reading the abstract and the paper if these are significant or not. So as an example, I will explain to you how to mine the literature using the first and the topmost result. The topmost result is this paper, The Missing Link and Autosomal Recessive Short Stature Syndrome Caused by a Hypofunctional XYLT1 Mutation. This paper was published in 2014, and by reading the abstract, I can understand that the mutation co-segregated with the phenotype in the family and is not found in over 13,000 alleles in the exome variant server, which means that they have done the segregation studies for this variant in the patient family. I have already downloaded this paper and kept, and let's go through the paper now. So this is the study. Let's search this protein change in the paper. This is for the abstract. The next line is from introduction, which states that they have identified the homozygous missense mutation in the patients. It is hypofunctional in nature. So in this right table, they are saying that they have two patients, 3.1 and 3.2. Both have the same protein change, both are homozygous, and they had the same nucleotide change as well. They are siblings. And as you can see from the pedigree, as well as the table, their parents were had consanguineous marriages. 2.1 and 2.2 had consanguineous marriages, and they had 4 kids, from which 3.1 and 3.2 had the disease. So let's go on to the results now. As you can see in the next figure, 3B has given the Sanger sequencing result from the sequencing of the patient and their family. And you can see both 3.1 and 3.2, which are patients, have this homozygous mutation C41441T in homozygous manner. However, their parents 2.1 and 2.2 have this in the heterozygous manner. You can see there are both C and T present here in the Sanger sequencing results. So this basically confirms that this variant was co-segregating with the disease in this family, and it is a supporting evidence of PP1, that is co-segregation in the patients. So we can say assign PP1 supporting evidence criteria based on this evidence from this paper. Along with this, there are a few functional studies performed as well, which basically understand the expression differences between the patient as well as the controls. So the study states that they found no obvious differences between the patient and control fibroblast expression for this particular gene. Also, this was the same for the protein activity as well. However, we cannot give any evidence, any criteria of ACMG and AMP guidelines based on this evidence, because these evidence do not completely cover all the aspects of this gene and its function. Therefore, we need further information to be able to give either PS3 or BS3, which are the functional criteria of ACMG and AMP guidelines. Therefore, on the basis of this study, we were able to give PP1 supporting evidence because the mutation co-segregated with the phenotype in the family. Now we have to further search for this variant in PubMed as well as PMC. So you can see when I put in the protein change in PubMed, I could only find one result, which was the same study that we studied right now. Therefore, with the protein change, our search has been thorough and there is no further information that we can collect now. So let us move on to the search with cDNA change. And I will put in the cDNA change in different databases now. For example, here I have put in the cDNA change in Google Scholar and I got 7 results, from which we have to read all these papers. However, because of the time constraint, I will only show the first result, which is this 2017 paper. I have read the abstract and it says that the HeLa cells were transfected with mutated XYLT1 plasmids, and this mutated plasmids, from these mutated plasmids, one of the plasmids was a variant of interest. Therefore, this gives me a hint that this paper might contain functional study for this particular variant. I have already downloaded the paper and kept. And since I searched this with the cDNA change, I will put in the cDNA position to search the significant text. So you can see in this table, for this particular variant, past literature that have been there have been shown, and this basically shows the paper that we referred to earlier for giving the PP1 criteria. This means that our search has been thorough till 2017 in terms of novel papers for this variant. This paragraph basically tells how the mutant plasmids were generated and is the method how they were done. If we check the figures 2 and 3, if we read the legend and understand the figures 2 and 3, we can see that the mutant protein is mislocalizing in endoplasmic reticulum in place of Golgi apparatus, and therefore this could be a cause of reason why this particular variant is a cause of the disease. This was further confirmed by figure 3, in which they showed the ER retention, and if the protein is retaining an ER, it cannot perform its function in the Golgi. Therefore, we can assign PS3 criteria based on this particular evidence. So we have assigned the criteria to this variant. We will now do further literature search and search this variant with the cDNA change in PubMed. And as you can see, I only found one result, which was the same paper that we studied right now. Now we will also search on the basis of RSID for this variant. When I did the RSID search, you can see that there were no results found. Therefore, we can say that our search has been thorough. We have assigned PP1 supporting and PS3 criteria on the basis of these two literature to this particular variant. So these are the ACAMG and AMP guidelines based criteria that we have assigned this particular variant, PS3 and PP1 supporting. So these were assigned based on all the literature that I have read on the back end. However, I have only shown a few examples for this particular variant, and I will do so for the other variants as well due to time constraint. But make sure to read all the literature for these variants so that you can get a comprehensive and holistic view of the criteria that can be allotted, or the information that is provided for these variants in the literature. Now we will move on to the next variant, which is S309T of B3GALT6 gene, which causes Ehlers-Danlos syndrome. So for this variant also, we annotated using VEP, and we got everything: gene name, cDNA position and change, protein position and change, and RSID. We will put each one of these ID into Google Scholar and PubMed to get the specific literature. So as you can see, I have put in the protein change for this particular variant, and I have got three results, from which I will show you an example by opening the first result, which is this one. I have already downloaded and kept the paper, but let's see what the abstract says. So there is nothing specific to the variant in the abstract, but let's read the paper first to ascertain if it's a novel paper, an important paper for a variant or not. So let's search since we got this paper using the protein change, let's search using the protein change only, which is S309T. So I put in 309 in the find. And as you can see in the molecular analysis, they are saying that Sanger sequencing confirmed the two previously reported variants in the single exon of the B3GALT6 gene, which are namely this. So they are saying that they found our variant alongside deletion variant, that is a frameshift variant. So, and they're saying that the frameshift variant was inherited from the father and the missense variant was inherited from the mother. So they are saying that there was co-segregation of the variant with the disease, as well as there was trans compound heterozygosity also. So it is safe to give PM3 as well as PP1 to this variant, because the other variant is a frameshift variant, which has been found in other patients also. So therefore, we can, with using this study, we can give PP1 supporting as well as PM3 to this particular variant. So I have put in PP1 as well as PM3 for this variant. Now let's search using this protein change on PubMed. When I did that, I did not find any specific literature on PubMed. Therefore, we will move ahead and search using the cDNA change, which is C.925T2A. When we do this on Google Scholar, we get 6 results. These are the 6 results that we get. From this, I will pick up the first study as an example. However, we still will have to search all the literature for specific papers. So this was the first study, which is mutations in B3GALT6 gene, which encodes a glycosaminoglycan linker region enzyme, cause a spectrum of skeletal and connective tissue disorders. So let's see if there is anything specific to the variant in the abstract. So by reading the abstract, we do not find anything specific, variant specific here, but we will still have to read the paper to make sure there is a variant study there or not. I have already downloaded the paper and kept, and I will search using the protein, the cDNA position, that is 925. So from this table, I can see that. So the next variant is G14S from JAGN1 gene, which causes severe congenital neutropenia. So I have already fetched the IDs for this variant from EP, and I will put the protein ID in Google Scholar. You can see that I got only one search result, and when I opened this paper and read the abstract, I could see that they have said that they identified homozygous mutation G14S and E14D in 3 patients with this disease. Therefore, this could have co-segregation studies with it. So let's search the paper. As you can see here, they have shown the Sanger and pedigree analysis. And when we open this figure, we can see that in this pedigree, the parents 1, and 1, 2 are heterozygous for the mutations. They had consanguineous marriage, and their children, all except this 2, 5 was mutant homozygous for this C40G2A variation. Therefore, this variant was co-segregating with the disease in this family. Also, they showed using multiple functional assays that this particular variant led to a dysfunctional JAGN1 protein. And for instance, in figure 3, they have showed that if there is increased apoptosis in mutant JAGN1 expressing HL60 cells. So therefore, this paper has sufficient evidence to ascertain and assign PP1 supporting due to this pedigree and PS3 due to the functional assays that have been given in this particular study. So we will go ahead and assign this PP1 supporting and PS3 to this particular variant. Here I have stated these. Let us mine more literature. So when I went to PubMed to search for this particular variant, I did not find anything. So I went ahead to search for the cDNA change in PubMed and Google Scholar. And in Google Scholar, there were 4 results. One of these, the topmost is the paper that we had already read for this particular variant. So for this particular variant, which had PP1 supporting and PS3, we have to explore the other papers as well. And when we went to PubMed, there was no result found. So from the paper that we read, we could give PP1 supporting and PS3 to this particular variant. However, we still have to read the other papers. Now we have to go ahead and do the literature mining using RSID. And as you can see, neither in Google Scholar nor in PubMed, I found any significant studies for this particular variant using the RSID. Therefore, reading that literature that we read together, I could assign PS3 and PP1 supporting to this particular variant. We will have to read the other papers that have been shown to assign the other criteria. Therefore, we could give PS3 and PP1 supporting to this JAGN1 variant. Now let's move on to the next variant, which is example 4, S409P variant of MAN1B1 gene causing Rafik syndrome. So we annotated this MAN1B1 variant, and these are the different IDs of this particular variant. So let's start with first putting the protein change into Google Scholar. So here I have put in the protein change in Google Scholar, and I have gotten 6 results, which are these 6. From this, I will show you the example of the first one, although you will have to do all these 6. You will have to look into all these 6 results to make sure that they do not have any significant or important information. So the first result is this particular paper. So after reading the abstract, I do not get any idea as to if this is important in terms of the variant or not, but let me still search using the find tool. So here they are saying that the variant detected in MAN1B1 encoded the C.12225P2C variant in a homozygous state in their patient. So, and next, they are saying that their case 2 is a compound heterozygous for the same missense mutation, that is S409P, along with a nonsense mutation. And in figure S1, as you can see, where the left panel is the maternal allele and the right panel is the paternal allele, you can see that, however, the patient is homozygous for this particular variant. Similarly, in case 2, you can see that along with a nonsense mutation here, you can see that the patient was heterozygous for this particular variant also. So therefore, we can give, since they are present in trans in the case 2, trans compound heterozygosity, along with the nonsense mutation, we can give PM3 to this particular variant S409P. And since it is segregating in this family, case 1 family, as well as case 2 family, we can give it PP1 supporting criteria as well from this paper. Now let's search for other type of studies in figures that have been done for this variant. So as you can see, the steady state level for MAN1B1 is very low compared in patient 1 and patient 2 compared to the controls. So this suggests that even in the homozygous state, which is in patient 1, this particular variant was leading to low levels of steady state, thus giving us a clue that this variant is actually putatively pathogenic. So therefore, based on this study, we can give PS3 also according to this particular study. So we have given PS3 to this particular variant, we have given PP1 to this particular variant, and we have given PM3 to this variant according to this, this study that we were reading right now. Now let us do further literature survey using the cDNA change. So when I put in the protein change in PubMed, there were no results. But when I put in the cDNA change in the Google Scholar, I found 4 results, from which this is the first paper. Yeah. So you can see in this case 6, which is in case 6, there was maternal allele as a deletion, and the paternal allele was an allele of interest, that is C.1225T2C. And it was, since it was present in trans and it was showing segregation also, since they have studied the maternal as well as paternal allele, we can give it PM3 as well as PP1 depending upon this paper also. So therefore, we can add this paper also to the evidences that have been collected for this particular variant. So we will put in this study also as an additional evidence here. Now we will search using the RSID of this variant. So as you can see, neither the Google Scholar nor PubMed gave any results when RSID was searched in these browsers. So as of now, 3 criteria have been assigned to this particular variant based on the literature that given it PS3, we have given it PP1, and we have given it PM3. So now let's move on to the next variant, which is G1061E from ATP7B gene, which causes Wilson's disease. So again, we have annotated this variant using VEP, and we will put in the protein change now on the Google Scholar. So after putting in the protein change, we got around 44 results, which means that this variant is very well studied in literature and has a lot of papers. So I will show you the first paper as an example, but you have to go through all of the papers to make sure that you cover all the important and novel studies for this variant. So the first paper is this particular paper. So to see what they're talking about for this variant, I have done a search for 1061, which is the variant name. So as you can see, they have done some kind of functional assays for this variant. We will now see what type of functional assays have been done. So here in this figure, you can see that they are saying that they have checked the normalized expression of ATP7B mutant versus the wild type, and they can see significant decrease in the expression of mutant ATP7B compared to the wild type. So this means that this particular variant is causing ATP7B to express in a decreased manner, and therefore this study can be used as a functional evidence to give the PS3 criteria for this particular variant. However, there are no segregation or population or any type of studies that have been shown here in this paper. So we can just go ahead and give PS3 to this variant using this paper. Now we will check PubMed. So the first paper, this analysis of Wilson disease mutations, this paper has already been studied when we were doing the Google Scholar search. So we don't need to review it again. So basically, from the papers that we have read, we could give PS3 from this paper. Now let's move on to the cDNA change. So when I put in the cDNA change in Google Scholar, I found 23 results, from which the first result was this study, where again they have studied multiple patients, that is patients from 109 unrelated families. I have downloaded this paper and kept. So this is this paper. And as you can see, the paper does report that new patients have been, it's a follow-up study basically for the earlier study that they did, and therefore it is not novel in terms of the patient's genetic information, or it's not important because it has not given the segregation or compound heterozygosity status. Therefore, we can ignore this paper also. When I searched PubMed for this particular variant, I have downloaded and kept it separately. So it's this paper. When I searched the protein change or cDNA change, I could see that This was a population study paper which understands the aspect of the allele frequency in this population. However, there was no odds ratio that had been calculated, therefore, or there was no segregation study that had been calculated, therefore we can ignore this paper also. Also, when I searched using the RSID, no results came in either Google Scholar or PubMed. So for this variant, we were able to allot only PS3 because there was no clear segregation state criteria that was given, or there was no clear compound heterozygosity or odds ratio type of information given, stated very clearly in a study. Therefore, I could only allot PS3, even though this variant was very well studied and found in multiple patients in literature. So this is all I could assign to this particular variant. Before you go, there are a few do's and don'ts again, like we described in earlier session, that you have to search using all IDs as we discussed earlier. You have to use 1 letter as well as 3-letter nomenclature for amino acids while doing the protein chain search. You have to make sure that publications that you're searching are related to the variant of interest specifically. For this, you can do multiple things, one of which is you can check with the abstract, or you can look into the keywords, whether they mention the variant or not. The publication being referred should be relevant and associated with the disease of interest. Sometimes the same variant can be associated with multiple diseases. So you have to make sure that that particular study which you are studying is associated with your disease of interest. The clinical consequence is clearly understood with the help of any functional assay. The functional assay should be specific to that particular gene and the disease that you're studying. And it should be such that the effect should be at least greater than 50% in affected as compared to the wild type. This is an arbitrary number and it depends upon what is normal in the field for that particular gene, but for majority of the cases we take 50% as the cutoff. And you make sure that you do not miss any details of the pedigree and supplementary images in the text, because sometimes people put in the segregation or the functional assays in the supplementary images or the pedigrees. Do not consider associated studies which have odds ratio less than 5 and confidence interval for this odds ratio calculation should be greater than 1. Make sure you do not miss the references in the tables for the variant in question. Sometimes, even if you miss an important or novel paper by searching through the literature, you will mostly find them in review papers or in reference tables which are mentioned in other follow-up papers. So make sure you do not miss those. And in case of variants which have multiple annotations and multiple transcripts, you start with the canonical or primary transcript of protein, which is mentioned in ClinVar or in Ensemble. But you have to consider all possible transcript isoforms to make sure that you are actually getting specific literature for your variant. Thank you.